is me, Miss Halogen. More salt, right away. Oh, hi. Didn't see you there. I'm Halley Halogen. Welcome to Chemistry Kitchen. Today, we're going to explore different areas of the kitchen through chemistry. First step is to look at our fan mail, our letters to me, Halley Halogen. Then we'll move on to a simply spectacular recipe for ginger creme caramel. See you in just 1 minute. Hello and welcome back to Halley Halogen's Cooking Chemistry. We're going to start with a letter from you guys. Dear Miss Halogen, I've been cooking for years now and I don't understand fully what butter is. Should I use the unsalted butter or should I stick with the regular? Help me out. Signed, Butter User. Okay guys, let's put on our chef hats and answer this question. Here's some butter for an example. Butter is a dairy product, first of all. It's saturated, which means that at room temperature it's at a hard state. When it's heated up, which many recipes call for, it'll be liquid, a liquid state. Butter has fat globules in it. Fat globules are really, really, really tiny and quite disgusting if you think about them. But for some reason we still enjoy butter immensely. Let's talk about fat globules. Here we go. The fat globule membrane is composed of surface active materials, phosphorus liquids, and lipoproteins. Now you're going to need some liposuction if you eat too much of this guy. So keep it in moderation, but it's still very delicious, and I hope you all at home enjoy your butter. I know I do. Any last words about butter? Butter is mostly just fat, but it actually is very close to whipped cream, so don't need too much of that either. Alright, we'll be back in 5 for more news. We're talking about making ginger creme caramel. Welcome back to Halley Halogen's Chemistry Kitchen. Right now we're going to be working on ginger creme caramel, which is a delicious custard with a nice little sauce on the inside. We're starting with the sauce. Come on over here to my cooking station. Oops, sorry. What you first want to do is take 1/2 cup sugar and add it to a saucepan. Okay, heat over medium heat. And immediately add 1/4 cup of water, making sure that every single sugar, every little bit of sugar is covered with water. What we want to do now is just let it sit for 10 minutes or until it gets golden. Now the reason this sugar evaporates or becomes one with the water is because they are both polar substances, like dissolves like. In a matter of time and with heat added, they'll turn golden brown and turn into a nice caramel syrup, so to speak. So what I'm going to do is just leave it alone for 10 minutes. And once it gets golden brown, you're going to want to immediately add it to your custard cups. And we're going to show that to you. We're going to have a little quick jump ahead right here. I don't know if you can see this, but the sugar is being picked up by the water and brought to the top. And the whole thing is becoming one slowly with this crazy boil. You can see right in here there's still sugar on the bottom, but it's being raised up in these little tiny bubbles over here. And what you also can't see is that the liquid is slowly becoming harder and harder the more the sugar and the water become one. And as it cools down, it will actually become a solid block, even though right now it's boiling and everything's moving. It's very interesting as it cooks. It's moving faster and faster with the more heat added and the longer it's been in here. So looking pretty crazy right now. As you can see, it's slowing down. The bubbles are becoming much larger and there's no more sugar in the bottom. It's all one, and it just looks like it's getting really, really hard. This is the point where you gotta really watch it because it can turn golden brown at any time. But if you wait too long, the golden brown turns into dark brown and it suddenly becomes disgusting to taste and bitter. So. It's gotten to be almost a little bit past the time it looks like it's a little bit too brown. It's going to be an issue. But as you can see, it gets colder on here and it actually starts crystallizing at the bottom and it looks really cool. It'll start hardening from the bottom up as it gets to room temperature and it'll slowly become just one hard molecule. Now in here, it's really, really hard to get out when it is room temperature, so you have to wash it out right away or heat it up later and wash it out then. When it reacts to the water, it suddenly becomes hard because it was colder. And you can see, it's just hard.
No, we can't.
Sorry, you can't see, but it's hard right there because it suddenly reacted with the water. It's just it's a solid block. I'm gonna soak it for a while. All right, as the first step for ginger crumb. Look how hard.